Okay, now recording part is on. Now next part is calling your data, fetching the data on your this interface Jupyter Notebook. And for this, what will you do? First here I am writing a work. I have converted my code cell into Markdown cell for writing something. Here writing uh, path to your CSV file. See, this is converted. Now writing for how to call this path. For this, you have to make a folder on your desktop. Okay, on your desktop, make a folder. Give the name something if you want. Okay, and keep this data file in your folder. Okay, and how to know your this folder location? There is two way. The first way is you have to right click mouse and go to the properties. See here the location of your file. See user cinema desktop, and folder name is new folder. Just backslash and write your folder name. Okay, new folder, and write here the this one, see user schema desktop new folder. Okay, this is your location. Just copy here from sorry, just copy here, and you can paste directly here in your this. Now writing, if you need this folder name path, then you copy this one. Now how to fetch this one? Now next is to load the data on your this CSV file. Then for this, write here the data, make a variable data underscore path. Okay, and is equal to this is a readable file R and postfs. Okay, just copy and paste, Control V, and C user schema desktop, and my folder is not new folder. This folder name is 2 days. This is my folder. Just copy this one and paste here. R is written for because it is a readable file. Okay, now close this one, and the file name is your data dot csv. Now close indentation, Control Enter. Or okay, now with the help of the this write only data underscore path, Control Enter. This is the path. Okay, now next things, see the path of your data, generate another cell. Okay, now how to load this data? For loading the data, you have to define your a variable name. Suppose that I am defining the variable. First define the path, now define the variable. Df is equal to pd dot read underscore csv, because this is a csv file format, and read underscore csv is a function, and pd is used for the pandas because we are working in a frame, data frame, and we have called it as a import pandas as pd. We cannot write a pandas is very big, that's why calling as pd, already defined. Okay, and now this path is data underscore path. Now write here df, then this will fetch your data. See, in a data frame you can see xyz groundwater level depth and hydraulic head, which we have converted. This is the way for fetching your data on your Jupyter notebook. Now we will do different process in this CSV file. Now first things we will see the its descriptive statistics through the visualization, and the best way for visualization for a descriptive analysis, box plots is a good way. Then we will use function SNS. So why we are writing here the SNS? Just see here, import Seaborn as SNS. Okay, and Seaborn, why we are using the Seaborn is it using a statistical analysis. Okay, C SNS, and they use the function box plot, and close with indentation, parenthesis, and write the variable which contain your data df, and this we are interested in hydraulic head, and this must be in a list. Okay, in list, and this is a string type. Nature of this is string. Just copy this one and paste here, close this. Now comma, uh, use the dist, and in double inverted comma use the nor. Plot is equal to plt. Why we are using the plt? Why we are using the plt? Because just see, import matplot.plt as plt, because we are plotting feature we are doing. Okay, now written here, if you want to write the title something, then plt dot title, and in addition write box plot of hydraulic head. And for plotting the using the function plt dot show, plt dot, and whenever you write the function in it, always use the parenthesis control enter. In line number 1 there is some name SNS box plot is not defined. SNS box plot is not defined. What is the mistake in this? Can anyone here SNS dot must be. It is something written here, plot show box plot this non plot plt. Mm, access dot box plot got an unexpected keyword dist. Okay, dist is oh, here unexpected keyword this. I hope this will work now. See, now you will able to see this is the box plot of your hydraulic head. Now, why the first way, visualization way for analyzing the descriptive statistics is the box plots is the best way. Here, this is called the from here to here is called the whiskers. From here to here called the whisker, and this is the called the box. And this together, box and whisker is called the box and whisker plots. And this dotted line is called the outlier, which is beyond this line. This is represent this line is represent it's a maximum limit of your data set. It is your minimum limit of data sets. This is your median. This is the first quartile length. This is the second quartile length, and difference between this the interquartile range. And this is outlier value and which represent anomalies. And anomalies, what is the anomalies? Anomalies is certain abnormality in your data set. And when you are doing research, then always focus on the anomalies, because anomalies gives you the novelty of your research if you are doing the research. Okay, now you are able to see how this box plots is saying. Uh, you can see the more feature if you're going to the Google. Just go to the Google and know about the box plot. What is the box plot? See, a box plot and whisker plots are a diagram, otherwise unknown as a box plot, is a graph summarizing a set of data. The shape of the box plot shown as how the data is distributed and is also shows any outliers. It is a useful way to compare different sets of the data, as you know, as you can draw more than one box plots per graph. Okay. Now here, see, this is the outlier. If the values are coming here, then beyond this line, then this is called the inlier. Definition. See here, this is the outlier. Two outliers which have the same value. This is the inlier, and this is upper quartile value. This is the lower quartile value. This is the minimum data value. This is the maximum data value, and this is the median value. Now next we will plot on our data sheet, that is we will do descriptive statistics. See some descriptive statistics, and for this just copy this one because I don't want to write again and again.
So excuse me.
Yes, please.
So no doubt it's very good to see that how the this data we plot in the Python. So if suppose I want to plot in a very simple way that the x-axis and y-axis and the graph is simple one, just the hydraulic head is decreasing or increasing. So where I choose this type of thing is this type of
This is,
ideas.
yes, this is coming.
You
This is
got my
coming.
point.
Yes, yes, I have got your one. This is the coming. Don't worry about these things. The first things you cannot do without these things, because you have to activate this library. Pandas is working in a data frame. Without pandas, you cannot fetch this data in your Jupyter notebook. And your matplotlib, you without this library you cannot plot any graph and feature. You cannot plot any type of the graph. Import Seaborn as SNS. You cannot do the statistical part. You cannot do the SciPy is a sub library for the Seaborn. Import GeoPandas. You are doing a, because in this data your spatial data, it's which location as given. Then you have to GeoPandas. You have to given, and geometry, every special data have a fixed geometry. Then you have to call this sub library from geopandas safety.geometry import point, because we are going to plot this point. And now I will come to your this question, how hydraulic head are increasing or decreasing. I am coming everything I will show you, because it's basic to advanced, and without this I finishing this I cannot finish this training course. You will train
Okay,
up to
sir.
the Modflow
Just
model.
just 30
Okay.
seconds.
Yes, it is coming. Your things are coming, but box plot basic. Whenever you analyze any data, the first things you have to analyze its descriptive statistics, and the best graphical representation of descriptive statistics is the box plots. Now we will see the some numerical part of this. Numerical means how descriptive statistics numerically can be analyzed. Again, we will upper and convert this cell as a markdown. And right here the descriptive. Here df dot is only you have to write here print, just finish this and write the print function and calling your df is a variable and which contain, variable is a container, I have already told you, and which contain your data. That's why your df, and we are interested in the variable hydraulic head, and this is written in the list, and written form of the list is in a big bracket, and nature of the your column head color value of the column in the header value of the column is a string. That's why it is written in a double inverted comma. Now use another function, that is a dot describe, des cribe, describe. Okay, now see hydraulic head D type and float is 64. It's there are 77 data in your this data column. Just see, count this here. The count 78. One is the header point. Otherwise, data is a 77. Let's see here. The data is a 77 response. A max minimum value minus 38 something. Maximum value this for we are interested in this way. Maximum 40 401 and minimum is the 120. Minimum value is one, mean of your hydraulic head is 178.06, standard deviation 70.64. Minimum value is this one, first quartile is this, middle quartile is this, and fourth quartile is this. Maximum value of your this one 40141. Now next things, this is the numerical way for descriptive statistics. You can check here, minimum value is your minimum value is 100. Just see here 100, this represents the minimum. Maximum value is your 401.41. Just see 4041.1, and it is the outlier value because it's beyond the maximum. If you want to outlier the role of the outlier and layer is very important in your data set. Okay, and how to know outlier are present in your data or not, you can check from here to the box plot. Okay, next plotting result is we will see QQ plot, we will see, and again I'm converting this cell to the as a markdown, and right here the no need to write more than more. Unmatched. What is given here? Line number one. Norm is not a valid distribution name. Is there any? Okay, now it is extra spaces. Now this is the QQ plot, and why we are plotting QQ plot, quartile plot, because whenever you want to check your data is a normal distribution or normally distributed or not, you have to check this through the QQ plot. If this blue dots are your data points and this is your quartile range, if this data perfectly lie on this straight line, then you can say that your data is behavior is a normal distribution behavior. Okay, this is the way for this. It means your data is not natural. This will be more clear with the histogram plot. Again, convert this markdown cell right here the histogram. I don't want to write again and again, so I copy. Okay, copy this one. Now using the cns dot hist plot function is hist plot for the histogram. Let's plot here. Now it's remove these things. KD is for your its peakness of this. True. No PLT song. Okay, see, this is the histogram plot. A nature of this histogram, so this is your a skewed plot. See, this is not a, if it's a normal distribution, then the see how normal distribution looks like. I will show you on Google. Now, normal distribution. I want to show some. Okay, first we will see the normal distribution, then we will see the skewed distribution. See, normal distribution is a perfect a bell-shaped curve, and how skewed distribution looks like. See, skewed distribution. This is the positive skewed. See from your data set. If you just click on this, hump is your lower side and tail is your higher side. Then from this, it's a positive skew, and this pickedness of this here is a mode. This is the median. This is the mean, and normal distribution is symmetrical type distribution. Mirror image of the one half at the middle. This is the mean median mode, and this is the negative skew when the tail is at hump is at higher side, and the tail is at lower side. But is the positive skew distribution. Now our data set is showing a not a normal distribution, a skew distribution, but it is showing you histogram. This one, but you can check it is a positive or not a negative skew distribution. You can check on this from this plotting. It is clear that now what is this graph is telling to you. Just focus on this mean. Mean is 178.061. Okay, it means that most of the data, if it is positive skewed, then most of the data value is lower than the 178. You can check here, just see number of data set. Just take the filter on your this, and the filter less than or equal to 178. 52 data are which is less than 178. It means if it is a your data is a negative skewed, then mean is 178, then it means that the dominance of the data is more than 178. Okay, this is the meaning of the positive and negative skewed. This I have shown you. Now next things we will plot some. We will do the some normality test. Again, we will convert this into markdown cell. And for this we will use Jack's Sapario test. Okay, use right here. First, define your a variable. Function is Sapario. Sapario. Okay, Sapario. I'm not going right many times. These things. Okay. Modulus scipy dot state has no attributes separons. Okay, you have to install another module for this novelty check. We will see this later because we have to search which under which module this novelty test is work. This module scipy dot stats. In this way, this is not coming. Now next we will see some plotting results of this. Okay, special data point. We'll see here. Geometry. We have already called the for geometry in there. If you see here, which library we have called here. Where is this library? Is this one? Safety jar geometry, which is under work in the GeoPandas library. It may be possible when you importing this library, there is error come. Then the first you have to go terminal part and install pip install pandas, pip install matplotlib, pip install cbon, pip install geopandas. Then this will work. Okay. Now GFT and see this is your spatial distribution your data points in which you're the here the density of the maximum density of data points is 30, and it means the higher groundwater level is existing here and the lower groundwater level is existing here. And special product groundwater, not depth, this is the basically hydraulic head. See, now point use define a library geometry. Here the point is your variable. It's a function for fetching the points, and points x y is your special points in which x y, and y is given here. Just see watch here x and y. Now see for x y in zip df is your variable which contain your data, and actual your x is format x and df is format y. Now again define a variable gdf and use the function gpd dot geo data frame. Here the your data set df variable and geometry, and is equal to geometry because this is in a shape. Now gdf dot plot use the geopandas library, and this is not for actually this is for hydraulic head. I want to show here. This is this one. Copy this one and paste here. Which variable you will paste, then show the feature of this. The maximum is here, then it's just showing minimum is here because it's just reverse. If the nature of which I told you, this is your hydraulic head, okay, and this is your groundwater level depth. When you subtract from the data plane, then this will get here. So it is showing the reverse. Maximum value is here and minimum is here. Okay. Have you any problem till here? Till now, you have any problem? Please ask.
No problem.
Okay. Now we are going to some another thing. That is your. We'll see some terminology in and concept, hydrology concept and terminology. First, we will see basics of the hydrogeology. We'll see opening in rocks, and we will see subsurface water condition, and we will see porosity and types, and last we will see basics of permeability and isotropic and anisotropic concept in hydrogeology. Basics of the hydrogeology we will see. Hydrogeology is the sub-region of the science of hydrology, and that deals with the occurrence, movement, and quality of water beneath the Earth's surface. Fresh water makes up only 2.5% of all the water on Earth, but not all of this water is available for human use. Groundwater is the second largest reserve, 30% of available fresh water on Earth, following the polar ice caps, which is 68% of the total reserve. Subsurface opening large enough to yield water in a usable quantity to wells and springs underlie nearly every place on the land surface, and thus make groundwater one of the most widely available natural resources. Ground water also represent the largest reservoir of fresh water readily available to man. The value of groundwater in terms of the both economics and human welfare is incalculable. Consequently, its sound development, diligent conservation, and consistent protection from the pollution are important concern of everyone. Now, surface reservoirs for groundwater and subsurface reservoirs for groundwater. Advantage and disadvantage. Surface reservoir high evaporation loss, even where humid climate and prevails, need large areas of land, may fail catastrophically, varying water temperature, easily polluted, easily contaminated by the radioactive fallout, and water must be conveyed. An advantage of the subsurface reservoir, that is the I'm talking about the groundwater, practically no evaporative loss, need very small areas of land. This is contained in the aquifer. Practically no danger of failure, water temperature uniform, usually high biological purity, although pollution can occur. due to some anthropogenic activity, not rapidly contaminated by radioactive fallout, act as a conveyance system, thus obviating the need for pipes or canals. Now we will talk about the opening in rocks. Uh, just see, this is a porous material, well sorted, and this is the primary opening. What is the primary opening? The opening during the formation of the rock, the opening formed due to at their formation of the rock. That is the primary opening. This volcanic rock, here the opening is present, and the volcanic rocks, when the form, then openings are present. This is called the primary opening. And this is second limestone. In this secondary opening, after the formation of the rock, if the openings are present, then this is called the secondary opening. And fractured rock, fracture in granite, and these are the secondary caverns in limestone. Now come to the this water phenomena of how rocks on the subsurface. This is the unsaturated water zone. This is a saturated water zone. This is a table. This is the ground, land surface, and surface water. And see, crescent rock, air is present, water not groundwater, and held by the molecular. This is the soil phenomena. So how the in soil there is basically moisture and air are present. Subsurface opening possibilities due to rounding, sorting, fracture. Now come to the Beddoes zone, capillary zone, and this way. Beddoes zone, it's upper the water table is called unsaturated zone where the pressure of water is less than the atmospheric water, and below the this piezometric surface, this is called the piezometric surface, is a capillary action is taken place. Capillary action is when you see the suppose that a string is put inside the glass, then you will see some water molecules catch the string and climb up to the string. Then this is called the capillary action, and this will work when this is below the piezometric surface, and upper the piezometric surface is the water pressure is less than the atmospheric pressure. Below the at the water table, water pressure and atmospheric pressure is equal, and in saturated zone, water pressure is greater than atmospheric pressure. And what is the piezometry? It is a line joining point of the your location of the unconfined aquifer, at which we will see later what is the piezometric surface. And this is called Beddoes zone and water table. And unsaturated zone, this is saturated zone. And capillary fringe occur at the above the water table but below the piezometric surface. We will see here this is the well, this is the soil zone, rivers and lakes surface, and this is the unsaturated zone, mediate zone, soil zone, and this is the water level, capillary fringe here, above the water table capillary fringe, and below the geometric surface capillary taken place. And this is the ground water and saturated zone, underground water. Now come to the porosity. Groundwater and soil moisture occur in the cracks, voids, and pore spaces of the otherwise solid earth material. Porosity and is what is the porosity? Porosity is basically a opening in the rocks. Groundwater and soil moisture occur in the cracks, voids, and pore spaces of the otherwise solid each material, and it is represented by n, and the volume of the void spaces to the volume of the whole rock, and multiplied by 100 is called the porosity percentage. Categories of the porosity: primary porosity and tertiary porosity. Category of the rock is first is the primary porosity, secondary porosity, and the effective porosity. What is the primary porosity? Primary porosity is formed in a rock during the process of the formation of the rock. Secondary porosity is that porosity in a rock after the formation of the rock. Suppose that limestone, you will find the secondary porosity, but in a volcanic rock, you will find the primary porosity. Uh, in limestone, due to crack and fracture is present, this is called the secondary porosity. And effective porosity, when porosity is the interconnected void spaces, when the void the this one formula of the porosity is a ratio of the void space to the whole of the volume, or volume of the whole rock. Then this is called the your this one porosity. Then effective porosity, when this volume spaces void spaces are interconnected, then this is called the effective porosity. Now the bulk density and particle density. This is the formula of the bulk density and particle density. Okay, we will see this one later because we have to explain this one. And what is the rock porosity? In cubic, the rock porosity is 47.6%. It's the highest porosity. If you want to know in which rock is porosity is very high, then you can say that in cubic form rock porosity is very high. But in Romo 100 packing, porosity is reduced by the almost 15%, 15 to 20%. Just see, it's when the shape has changed. Material well sorted sand and gravel. Porosity is a 25 to vary from 25 to 50. Sand and gravel mixed 20 to 35. Glacial till 10 to 20. Silt 35 to 50. And clay 33 to 60%. Primary porosity is sedimentary rocks clastic and igneous rocks crystalline, and metamorphic rocks in metamorphic rock and volcanic rocks, you will find the primary porosity during the formation of the rock. Secondary porosity, you can find the contracture fraction calling basalt, columnar basalt, fracture porosity in carboniferous limestone, solution large fracture porosity. Now permeability. Permeability is the property of the rock that is an indication of the ability for fluids, gas or liquid to flow through the rocks. Basically, permeability to allow the fluid to permit the fluid in a rock. Permeability is the high property of the rock that is an indication of the ability of fluids, gas or liquid to flow through the rocks. High permeability will allow fluids to move rapidly through rocks. Permeability is affected by the pressure in a rock. This is now this is the called effective porosity, when the permeability, when the permeability is depend on the fluid, then this is called the effective permeability. Isotropic and isotropic phenomena. Hydrologic properties, hydraulic conductivity, specific storage, etc. may vary through space within a geological formation. Okay, the spatial variation of hydraulic property is called heterogeneity. There are many types of the heterogeneous configuration in our geological environment. A good example is a layered heterogeneity common in sedimentary rocks and and consolidated lacustrine and marine deposit. See, isotropic, all direction is the same rock type is present. This is the anisotropic. Just see, in x-axis direction the same, but when you are going to y-axis, the nature of the rock and shaping has changed. This is called the anisotropic. Anisotropic and heterogeneity. What is the isotropic? Heterogeneous. This is the everyone is same. Anisotropic and heterogeneous. See, anisotropic. Why? Because in y-axis this is chain and x-axis is this chain. Isotropic and this is another type of rock type and this is another type of rock, but the nature of this rock is same all direction, but nature of this rock is same. That's why it is both are the isotropic. but heterogeneous because this rock is different and this rock is different. Anisotropic and heterogeneous in both the direction and property, spatial property is changed. Okay, the basic terminology of the this is the basic terminology of your hydrogeology. Now we will see more. The before seeing the more, we will go to the mod flow and flow pipe. Okay, we will see the mod flow and with flow pipe intro and installation, and we will do practical part tomorrow from 10 a.m. or 9 a.m. Table of contents. We will see what's mod flow and what is the flow pipe. What is the mod flow? Modflow is a US Geological Survey's computer code. It is developed by the USGS. It solves groundwater flow equation, public domain, that is free open source software written in Fortran. Now this is written in the Python also. That's why I'm showing here. The de facto software for aquifer simulation. And this is the very old. First version in 1983, latest version in the Modflow 6. We will see the feature of the Modflow 6 and we will use the Modflow 2005. Now, example of the Modflow, there are two pictures are here. One is the hydraulic head and second is the this one is the permeability conductivity hydraulic conductivity map. What is this is a heat map showing the spatial distribution of the logarithm of hydraulic conductivity values across a grid. Hydraulic conductivity is a measure of a material capacity to transmit water. The color scale on the right side of the map indicates the range of log K values, with red representing higher values, the blue represents the lower values, and the log indicates the values of the logarithm, which is common in hydrogeology to manage the wide range of the this one hydraulic conductivity. The presence of well is indicated by a circle, suggesting this is a location where water is being pumped out or injected into the ground. Now, next is the hydraulic head. This contour map shows the distribution of hydraulic head values in a meters across the same grid. Hydraulic head is a specific measurement of the liquid pressure above a geodetic datum. The contour line represents a location of equal hydraulic head. These lines are close together near the well, indicating the steep gradient caused by the pumping or recharge, which could mean there is either extraction or injection of water at this point. The dashed line with numbers represent the value of hydraulic head at this point. Okay. Now we will see some Modflow feature, why Modflow relevant program, and explain this figure. Evapotranspiration. This refers to the process which this is the basically shows the cover image for the mod flow process and how the mod flow uh, modeling is work. Okay. Now first is evapotranspir. This refers to the process by which water is transferred from the land to the atmosphere by evaporation from the soil and other surface and by transpiration from lands, plants, wells. In this one, wells indicate the module of the feature in a mod flow that simulates the extraction or injection of water by a wells. Rivers, this one represent the component of the model that simulates interaction between groundwater and river system. Drains, this would be the module that simulates the effects of the drains, which can either remove water from the system or act as a control outlet for groundwater. BCF is a BCF is here. block center flow package, which is used for the construction of flow model using block center finite differences. And come to the basics, indicate the basic package of Modflow that contains the fundamental elements needed for any groundwater flow model. SIP is strongly implicit procedure, a solver used to solve the matrix equation that arise in a Modflow. Here the Modflow program is working. Okay. SSR symmetric successive over relaxation method, another solver that can be used with the Modflow. Now, many other program based on the Modflow, so called the Modflow site. MP3 DMS is used for the transport. Modpath package is used for particle tracking. CWAT, we will see the CWAT, density dependent flow and transport in a coastal aquifers. It's basically it is the CWAT package is used for your contamination, just to show the contamination process. Pre-QC reaction, it is used for a pest and U code parameters estimation sensitivity analysis. Some commercial program with GUI, Visual Modflow, GMS, and PM Win. This is the commercial, and you have to pay. If you are using this software, you have to purchase or pay. But we'll do on the Python, and this is open access and free. Now, some see contaminator, how Morphflow is work. This is a conductivity permeability field and contaminated from 0 day to 3 day. We will see. See here see the day, how day by day contamination is increasing, and through the Morphflow modeling we will see in a 3D visualization. See, day by day contamination increasing and shifting towards the distinct side. Some comments on Modflow, if you want to do comment. Most widely used groundwater flow simulation software, even accepted by regulatory agencies and cited in uh, have undergone extensive review and improvements. Many recent updates on structure grid, better numerical, and now still lack of the graphical user interface GUI. These are, we will not go in this because these are the paid version. Now, basic groundwater flow equation is a 3D flow with constant density in porous media is described by this equation, where S is the specific storage and the phi is the hydraulic head, K is the hydraulic conductivity, Q is the source. This will be sink or open source or sink. Modflow is a finite difference method using block centered grid scheme, and this one FDM solves groundwater flow equation by approximating partial differential equation with algebraic equation by using uh, approximate. No, this is a part of the some theory. We will not go. Okay, now how Modflow grid will work? We'll one by one see. It's first see the this one. This is a column, this is the row, and this is the layer. Okay, layer of this, your aquifer body. Now, one by one, see what is this. Modflow modeler finite difference model. What is this? It is a widely used groundwater flow simulation software developed by the United States Geological Survey, and this will work on the Python, this will work on the Fortran, this will work on the others paid software that are like GMI, Waterloo, this. The Modflow grid refers to the computational grid used in the simulation, which is a key component of the Modflow model. The Modflow grid is a three-dimensional discretization of the groundwater system being modeled. It is divides the ground domain into a series of cells or grid. Just see here. This is a cells and grid. It divides the groundwater domain into a series of cells or grid, where each cell represents a volume of the subsurface. The grid can be structured regular or unstructured irregular depending on the complexity. Complexity of the groundwater system being grid may be how to grid design. Now we'll see. What is the dimension? The grid has a dimension in the x, y, z direction, representing the horizontal and vertical extent of the ground system. Now cell size. What is the cell size? Each grid cell has a specific size which can be uniform or vary spatially based on the needs of the model. The cell size plays a crucial role in the accuracy and computational efficiency of the simulation. Layers. Modflow grids are typically divided into the layers along the vertical axis. These layers represent the different geological formation or hydrostratigraphic units within the groundwater system. Each layer may have different properties such as hydraulic conductivity, porosity, and storage coefficient. Boundary condition. The grid defines boundary conditions that control the flow of water into and out of the model domain. We will see this all these through the practical. These includes specified head boundaries, constant head boundaries, no flow boundaries, and recharge discharge boundaries. Stress period. Morpho simulation are often run for multiple time periods known as the stress periods. The grid configuration may change between stress periods to simulate change in the pumping rates and recharge rates or other hydrological condition. Now, what is the finite difference equation? Just focus on this picture. Water mass balance is accounted for the summing of water fluxes across each side of the cell and internal source link. Method for accounting for the water mass balance in a system. Mention the this is achieved by summing the water flux across the each side of the cells, including the internal source or sinks. This is some equation for the Modflow modeling. This is a theory part. We will not go in the deep. Overall interpretation of this figure is that the image and structural illustration of how to calculate the flow between cells in a finite difference model. Okay, this is so, and this is the mathematical equation how when you will calculate from this in a grid from this cell to this cell, and how flow model will work. Cell type. Now this is your cell type. Each cell can active cell, variable head, inactive cell outside the domain. These are the inactive cells. Our aim to calculate the between this one. This is the boundary condition, constant and boundary condition. Active cell. What is the active cell? These cells have a variable head, which means the hydraulic head, and inactive cell. These cells are outside the domain. This is your boundary and outside the domain. The lower diagram represents a discretized grid of the cell used in a numerical groundwater model. It also shows IBAN code. We are not doing this IBAN code because we are working on this Python. Modflow after discretization. This is a theory part. We will see this how Modflow work after discretization. We will see. Now come to the FlowPy. FlowPy is a package in Python which is designed for to modeling for Modflow. Python package for creating, running, and post-processing Modflow-based model, often software environment that combines Python with Modflow side. FlowPy can generate inputs file for the Modflow family programs in a few lines of the code. Okay, installation. Python 3.6, use the pip install and write the flowpy. Then this will work. And this is a reference of this. Today we will stop here. Now next class we will do practical part, and from 9 a.m., 9:30 a.m. We will start, and up to the this 3:30. Okay, if you have any question, any doubt, please send me on WhatsApp. Will I will try to solve this. Hello, hello.
Yeah, I can hear you.
Yes, have you any question?
No.
Okay, then we will try to install Python and do work on this. I have set the code to all of you, and data I have already said, and notes I have shared. And tomorrow we will do practical part of the confined and unconfined aquifer, and we will see the pumping test results and how the pumping test result for the confined unconfined aquifer, and we will see some other features. The basics of the hydrology is today's basics. Now we will see the tomorrow we will see some advanced feature. Okay. Uh,
Okay.
Thank you so much for joining. Okay. Bye bye. Good night.
What time is tomorrow?
It may be 9:30. Okay, because today is late just because my some technical failure due to internet failure. That's why it is. But I will compensate tomorrow from 9 p.m. 9 a.m. We we will organize. Okay, I will send the link,
Okay.
and I will also send this today recorded video to all of you.
Okay.
Bye. Okay, bye. Thank you.